Alright, welcome back to Physics 11, and in this section we're going to be talking about the satellite motion, which is again an application of the universal gravitational law. Now we're going to be looking at the application of universal gravitational law only here. We're not going to be looking at different types of orbits. So as you can see in this animation, we have these little particles floating around the Earth, which represent satellites, artificial satellites. So if you're interested in different orbits, you can read section 6.6, I believe, in the textbook, which talks about elliptical orbits. But for now, we're just going to be looking at the application side of it, just looking at the universal law of gravitation. So let's take a look at our first slide. Consider that the Moon and the Earth are 385 million meters apart, and given their masses, we asked to calculate the force of gravity between them. So it seems like a pretty straightforward question. All we have to do is just use our universal law of gravitation, plug in the values for the masses, plug in the value for the r, and get the answer. So again, here are the values that we have, r and the two m's. So let's do some calculations here. So first, let's write down our equation. Force of gravity equal to universal gravitational constant times the mass of the Earth times the mass of the Moon over the distance apart them, so r squared. Plug in the numbers. 6.67 times 10 to negative 11 times the mass of the Earth mass of the Moon, and then the distance apart squared. And the answer that we get here is 1.98 times 10 to the 20th newtons. So that looks like a pretty big number. So how come, given that amount of force, the Moon doesn't just get pulled towards the Earth? Now the reason it doesn't get pulled towards the Earth because the Moon is in orbit around the Earth. And the orbit itself is perpetual motion, which usually is elliptical, but can be really close to a perfect circle, which the Moon is sort of close to a perfect circle. It's slightly elliptical. That's why we actually get high and low tides. So one tide is slightly bigger than the other. And this applies to any celestial body. It doesn't have to be the Earth. Like some planets have more than one moon. In our case, we only have one. And that's our natural satellite. We call it a natural satellite. So how do the objects actually get into the orbit? Because, as you know, we have internet, we have GPS because of satellites around the planet Earth. So we've launched a bunch of these, hundreds of them already, into space. So consider this scenario. We have a football that you're going to throw, and depending on the force you throw with, depending on the angle, it might travel further away or closer. So let's say if you throw it this way, it'll fall to the ground. Maybe if you add a bit more force, it'll go a little further, but again, eventually fall to the ground. You might be able to pitch it up in a different angle, but again, it's gonna keep falling to the ground because humans don't have enough strength to launch it with enough force. But let's say instead of just launching it by hand, you're standing on top of a mountain and you have a cannon with you that you can launch your football with. So let's say you add some gunpowder to it and you launch it, and maybe it'll go further, of course, than just throwing it with your hand. But again, at some point it will fall to the ground. Let's say you add more gunpowder and it goes further still, but eventually fall to the ground too. So that just means that the speed that it's going at, it's too slow. So too slow to stay in orbit. But at some point, you're gonna add enough gunpowder to launch it at the right speed, and it's gonna keep going further and further away. And again, because of the force of gravity is pretty much uniform around the Earth, it's gonna be going around and around and actually not fall because you launched it just at the right speed. So in this case, we have the right speed. To stay in orbit. But notice that at any point along this orbit, right, we still experience the force Fg. Doesn't matter where the football is, it's still experiencing the force of gravity on it. So it's constantly being pulled towards the Earth, but because it's gone at this right speed, it's still in free fall. And it just kind of keep going around and around. Now there's decaying orbit and there's stable orbits. So for example, the moon is in the stable orbit, so it doesn't decay over time, so it's gonna keep staying in the same position. So ideally you wanna have your satellites, whenever you're launching your like telecommunication satellites, to have a certain orbit, and you want it to stay at that orbit. Now they have different ways to correct their orbits if they need to, but eventually some of the orbits will decay because they will get out of the position. So they do experience force of gravity, even though we consider this a weightless position. So a lot of times when you go into space, you say, oh, you're experiencing weightlessness. But that's just a name for it, because they still experience the force of gravity acting on them because the objects still have mass. But again, because they're not just staying put, they didn't just jump up and down, they go in such a way that they're maintaining their speed. So they're gonna keep going in a circle and achieving orbit. So again, this is the description here, what I just mentioned. The football is still being pulled towards the Earth, however, at just the right speed, it will achieve orbit and not fall down. So just to summarize this, notice that at all times, again, the football is being pulled towards the Earth by gravity, and because of this, we say that the objects in orbit are in free fall. Okay, they're always falling towards the center of the Earth, but never actually reaching it. So this is just a quick application of the universal gravitational law. And after this, there is a worksheet 5.2, which deals with the gravitational field strength and the section on satellites. So if you have any questions on section 5.2, there are 8 questions there. Make sure you post them in the comments so I can go over any questions that you may have. Now, I'm not going to go over the questions right away, so I need to wait for a few people to reply, see if there's any questions that they want me to go over. So make sure you log in to Teams constantly, view the lessons, and post questions in order for me to create any sort of videos to reply with any of the questions. Okay? All right. That's all for now.